you are running an application in production that is leveraging Dynamo database as its data store, and it is experiencing smooth, sustained usage. There's a need to make the application run in develop mode as well, where will it experience an unpredictable volume of requests. What is the most cost-effective solution that you can recommend? Use provision capacity mode with auto-scaling enabled for both dev and production. Use provision capacity mode with auto-scaling enabled for production, and use on-demand capacity for development. Use provision capacity mode with auto-scaling enabled for dev, and use on-demand capacity mode for production. Use on-demand capacity for both dev and production. Use provisioned capacity mode with auto-scaling enabled for production, right? Because they said it's kind of stable, right? And use on-demand capacity mode for development. And on-demand is more expensive, but I think, but for development, the environment tends to be more unpredictable. Okay, so it's more unpredictable and less, so you'll pay less. Okay, let's go. You have an application running for over a year now using a database data table with provision to read capacity units or write capacity units without any throttling issues. There's a requirement for your table to support second type of queries, so you have decided to use the existing local secondary index and create a new global secondary index to support these queries. 1 month later, the table begins to experience throttling issues. After checking the table's CWM metrics, you found that you haven't exceeded the provisioned RCU and WCU. What should you do? The LSI is throttling, so you need to provision more RCU and WC to the LSI. Adding both an LSI and a GSI to the table is not recommended by AWS best practices, as this is known cause for creating throttles. The GSI is throttling, so you need to provision more RCU and WC to the GSI. CloudWatch metrics take time to propagate. You should see the RCU and WCU peaking for the main table in a few minutes. The GSI is throttling, so you need to provision more RCU and WC to the GSI. Oh, that the throughput is insufficient to handle the workload. It should alleviate the threat. It's worth noting when you add a new it consumes additional writes, so you may need to adjust your provisioning accordingly. I guess that could help. When you add a new GSI, it consumes additional read and write capacity. Okay. You are writing a CF template in YAML, CloudFormation template. The template consists of an EC2 instance creation and one RDS resource. Once your resources are created, you would like to output the connection endpoint for the RDS database, which intrinsic function returns the value needed. Sub, get at, find and map ref. Get at. Okay. The connection at one point typically includes details such as posting is used to get the value of an attribute from a resource in the template. Okay, good times. As a site reliability engineer, you are responsible for improving the company's deployment by scaling and automating applications. As new application versions are ready for production, you ensure that the application gets deployed to different sets of EC2 instances at different times, allowing for a smooth transition. Using code deploy, which of the following options will allow you to do this? Code deploy hooks, code deploy deployment groups, code deploy agent, define multiple code deploy applications. Code deploy deployment groups are logical groupings of instances or ECS services into which you can deploy new versions of your application and manage and control the deployment process. All right, good. The development team at a retail organization wants to allow a Lambda function in its AWS account A to access a DynamoDB table in another AWS account B. Which of the following solutions would you recommend for the given use case? Create an IAM role in account B with access to DynamoDB. Modify the trust policy of the execution role in account A to allow the execution role of Lambda to assume the IAM role in account B. Update the Lambda function code to add the assume role API call. Create an IAM role in account B with access to DynamoDB. Modify the trust policy of the role in account B to allow the execution of role of Lambda to assume this role. Update the Lambda function code to add the assume role API call. Create a clone of the Lambda function in AWS account B so that it can access the DynamoDB table in the same account. Add a resource policy to the DynamoDB table in AWS account B to give access to the Lambda function in account A. Okay, create an IAM role in account B with access to DynamoDB. Modify the trust policy of the account B to allow the execution role of Lambda to assume this role. Update the Lambda function code to add the assume role API call. That's what I'm really confused about. Having a call, an API call as part of the function. Okay.